Hi everybody, it's Professor Stevens. We're going to start looking at how to put everything together that we've been working on in previous sections of Chapter 4 to solve equations of different forms. And there's basically three ways of solving these things, whether it's an exponential or a logarithmic format to start with. These three basic methods can work. At least one of them is going to work, and possibly more than one. But as always in mathematics, there's not always just one way to work a problem, but there is usually a way that is most efficient or has the fewest steps. And so we'll be looking at that. We'll be comparing methods for different types of problems, but we also will find that some of the problems really can't work them unless you're using the correct method. All right, so right here summarizes, this gray box summarizes the three ways that you can solve exponential and logarithmic equations. So when you have an exponential, it really works best to take the log of both sides and make sure that the base is the same as the base of your exponential. So when you see that format, that's going to be probably the most efficient way in most cases. Take logs of both sides and make sure that the base matches the base of the exponent. Then if you have a logarithm with some sort of algebraic expression in exponential, so you would rewrite in exponential form. And I'm paraphrasing, and if you want to see the formal way that everything is worded, it is on page 444 of the book. 3, when you see a log equals a log and they have the same base, it's similar to how, like, if we had 3x equals 3 squared, you would know that x equals 2. Well, the same thing applies when you have like log of 3 equals log of x, then you would know that 3 is x, or x is 3, as long as the base is the same. So in that case, you would solve by doing, I guess you could equals g of x, meaning whatever it is that's plugged in to your logs, as long as the logs are the same base, then those two arguments are equal to one another. And then number 4 just lets us know that sometimes we have a complicated looking problem that might need to be simplified before you can apply any of the three methods mentioned above. So we'll be looking at different examples. And then the last thing here just reminds us that we have to check the proposed solution, because the domains of our x, some answers will be extraneous and need to be excluded from the final solution set. So if you were trying to plug something into a log that doesn't make sense, like a 0 or a negative, then you want to make sure you're checking your answers so that you can notice that and not include it in your final solution. All right, so let's start with some examples here. We have solving an exponential equation. We're going to take 8, raise it to the power of x equals 21, but we want to know what x is. The logarithm undoes an exponent. So let's go back. Oh, where was I? Here. Go back to my example. All right, so what I want to do is I want to get x out of that exponent, because I can't solve for x while it's up there in that exponential position. So by taking the log base 8, I will be basically applying an inverse operation so that I can get x out of the exponent. So the log base 8 of 8 to the power of x is equal to the log base 8 of 21. Now, we can use properties of logarithms to simplify this left-hand side. So we can put the x in front. And we can also use change of base over here so that we can evaluate it using a calculator. Or sometimes the directions say give the answer in exact form. This example wants us to round off the answer, but in some of them it'll say give your answer in exact form, and in that case you would not want to, you would probably leave it like it is here. But we can simplify something on the left as well, because we know that a logarithm is an exponent. So it's like saying 8 to some power equals 8, and then of course that power would be 1. So the log that has the same base and the same argument is always equal to 1. So that simplifies the left quite a bit, and so now we have x equals log 21 over log 8. And remember that when I don't write a base down here, when no base is written for the log, it is assumed to be log base 10. And this change of base formula is what is going to allow me to evaluate this using a calculator. You can also use the natural log. These both will give you the same result. All right, so let's evaluate that. So it comes out to be 1 point, said to round to the nearest thousandth, so 464. Okay, that's the nearest thousandth. So, excuse me. So that's our final answer right there. And then since I've been having you guys use Excel, Microsoft Excel as a calculator, I'll just remind you of what the functions are to use when you evaluate that. So in Excel, you would do log 10 of 21 divided by log 10 of 8, and that would get you the answer. That's using the change of base formula with Excel. You always have to put an equals in front of it inside the cell. So you would just enter all of this inside of one of the Excel cells in a spreadsheet, and you'll get the answer that way. You can also do ln, which ln means natural log with a base e, the natural number e, and you would do the same thing. Once you start typing in log and ln, you'll see them pop up, and you can double click on the function and input the values. And still another way, which does not require the use of the change of base formula, is I think it just says log, and you can put in your number that you're evaluating and then the base. And that's the way it's written when you see the little pop-up that shows you what to enter into the log function. But I would like to just note that argument is what we call that. So in other words, if you have a log, say log 21, then the base is 10, the argument is 21. So to evaluate that with Excel using this function that does not require the change of base formula, you would do equals log, and then you'd put in the argument first and then the base. Now the reason that I teach you how to do it with the change of base formula, like these two ways, is because you're going to need to know how to do that for certain problems. Because when you go on to calculus or pre-calc or wherever you're going next with your math, it's very important to know how to use these. So the change of base formula should not be ignored just because we have a way of evaluating a log of any base. All right.